Hello. Today we're going to be reviewing simplifying radicals. So when we're simplifying radicals, a couple of reminders. You're looking for number pairs under your radical. When you find number pairs, that's what you bring out. So for instance, the square root of 18, you're going to break it down and you're going to look for 3 times 3 times 2. Any pair comes out, any numbers left behind stay inside. This is called your radicand, is the numbers left inside your radical, and then your coefficient is the number out in front. When you multiply two radicals, you make sure you multiply the coefficient parts, then you also multiply the radicands, and then you continue to simplify. In order to add, your radicands have to be the same to make like terms. So for instance, if it was 3 root 2 minus 4 root 2, you could add those. But if it was 3 root 2 minus 4 root 3, you could not combine those. You can't have any square roots in the denominator. And so with the following examples, we're going to kind of address those cases as they come up. So we're going to take each of these and we're going to simplify them. If you have a fraction within a square root, you can try reducing, you can try taking the square root of the top, you can take the square root of the bottom, and then simplify and see if that works. For this one, I noticed that 63 and 112, both of those have 9, or not 9, 7. So if I divide each of those by 7, I get 9 over 16. And so dividing each of those by 7 now creates something that I can actually square root pretty nicely. The square root of 9 is 3, and the square root of 16 is 4. So we end up getting 3/4. I'm not breaking any rules because I have no square roots left in the denominator. For number 2, we're going to go ahead and try to combine these together. We cannot add them together right now. Instead, what we have to do is simplify them first. So we're going to go ahead and pull out number pairs. When there's something out in front, you're going to take and multiply those. So 3 root 12 becomes 6 root 3. And for the 75, you also can think of it this way. If you know the square root of a number, you can take the square root and pull that out. And so you're going to do 5 times 5 on the outside to get 25 root 3. Now the radicands are the same, so that remains root 3, and you add your coefficients. So we get 31 root 3. When multiplying radicals, we want to use our distributive property, so we're going to do 3 root 5 times 3 root 5, so we do 3 times 3, which is 9, and root 5 times root 5, which is 25. Notice this is different than adding. With multiplying, you still multiply the coefficients and you multiply the radicands. The next one then would become 12 root 15, then minus 12 root 15, then minus 16 root 9. After which we're going to go ahead and simplify. So the 12 root 15s cancel each other out. We have 9 times the square root of 25, which is 5. So that simplifies to be 45. Minus 16 times the square root of 9, which is 3. So minus 48. So 45 minus 48 becomes negative 3 in total. For number 4, we have this quantity squared. So instead of squaring each part, we actually have to write it twice and distribute. Otherwise, we're going to get an answer that doesn't actually work. So we're going to go ahead and use our distributive property to get 25 root 36 minus 20 root 6. Oh, minus 20 root 6 again, plus 16. And then we're going to continue to simplify. So 25 times 6 is 150. 150 and the 16 combined together to get 166. And we do have like terms here, so it's minus 40 root 6. So that's just a quick review of simplifying radicals, adding, and multiplying radicals. And now we're going to talk about dividing radicals. You can't have a square root in the denominator. That's breaking some math rules. So what we have to do is we have to do something called rationalizing the denominator to get the square root out of the denominator. So when you have something that is, you can't simplify anything right now, what we need to do is we need to multiply the numerator and the denominator by a same number so that we can get that radical out of the denominator. So we're going to actually take that denominator, the root 3, and we're going to multiply both the numerator and the denominator by that number. Because technically what we're doing is we're multiplying by 1, so we're not really changing the fraction, we're just changing how it looks. Now our numerator becomes 2 root 3, our denominator becomes the square root of 9, and that simplifies to just be 3, which gives us no more square root in the denominator. For number 6, you might be thinking, well, we don't have a square root in the denominator, but we technically do. If we were to take the square root of 56 and put it over the square root of 45, then we end up with that square root in the denominator. So looking at this, we do have to simplify this first. So this is 8 and 7 and 4 and 2. So the numerator here would simplify to 2 root 14. My denominator is 9 times 5, so that would give us 3 root 5 in the denominator. Notice my denominator is still one term. It's a monomial. So we can still rationalize it by multiplying by our radical. Now we don't need to multiply by the whole 3 root 5. The part we really need to get rid of is the root 5 portion. So the numerator would then become 2 root 70. The denominator would be 3 root 25. And the square root of 25 is 5. So that would then simplify to 2 root 70 over 15. It does not reduce any further because the 70 is under the radical and the 15 is not, so you can't reduce that by 5 at all. Now number 7 is here to show us the difference between 5 and 6 compared to 7. Notice the denominator here is a binomial. So if you're thinking, hey, let's get rid of that root 3 by multiplying by root 3, so what happens is our numerator gets 2 root 3, and our denominator would have to become 4 root 3 minus the square root of 9. So this actually, if we try to rationalize it that way, it doesn't end up giving us no radical in the denominator. We still have a radical in the denominator. So we haven't simplified our life at all. We just have a different place where a radical is. And multiplying by root 3 now still isn't going to help because it's just going to seesaw. It's just going to seesaw back and forth where that radical is. So instead, we have to find a different way. And that's where the conjugate comes into place. So a conjugate is going to take a binomial, which is what number 7 had in the denominator. You're going to rewrite the same binomial, but you're going to switch your signs. So whatever is in between them, you're going to change that. So for number 6 from above, or number 7 from above, it was 2 over 4 minus root 3. So you're going to take the denominator and you're going to multiply by the conjugate of the denominator, which in this case would be 4 plus root 3. And so when we multiply by 4 plus root 3, if you would like an algebraic expression as to why this works, you can see this kind of written out here, how all of the variables end up either canceling or being perfect squares, so therefore there's no more radicals. Or we can take a look at number 7 and show that's true. So we're going to distribute our numerator. It would be 8 plus 2 root 3. We're also going to distribute our denominator. It would become 16 plus 4 root 3 minus 4 root 3 minus root 9. And so this is exactly what's supposed to happen. These square roots are going to undo each other. They cancel each other out. The square root of 9 is 3. So my denominator really becomes 16 minus 3. So my numerator is 8 plus 2 root 3. My denominator is 13, and I no longer have square roots in my denominator. So this actually would be our final answer because nothing else reduces. You also can break this up into two separate fractions. I will write most of my answers like this, therefore, just because it helps to reduce correctly when you have multiples and things. Either answer is acceptable though. So here's what I'd like you to do. Take a look at 8 and 9 and identify the conjugates. So for 8, it should be 3 plus root 8. And for 9, it should be 4 plus 3 root 5. Then take a moment and pause the video and go ahead and distribute these and simplify them. Okay, so having taken a moment to go ahead and do the distributive property and then simplify, we can see that for number 8, after we distribute the numerator, there are two different things that need to keep simplifying. So we simplify each of those. The denominator, the middle terms cancel out, and we have 9 minus 8, which reduces to 1. And so therefore, if we take everything and divide it by 1, it just ends up with what's ever in the numerator. So our final answer for this is 6 plus 4 root 2 plus 3 root 6 plus 4 root 3. For number 9, when we distribute our numerator, we have like terms that we can add together. We also have some things that continue to simplify. So by simplifying those and combining like terms, our numerator becomes 23 plus 10 root 5. And my denominator becomes negative 29. So you can either write it as the first one, or you can write it as negative 23 over 29 minus 10 root 5 over 29. Either one of these is totally acceptable. Just note that if you would have to reduce a fraction, just be careful when reducing fractions. So now what we're going to do is we're going to finish up our square root review by using our square root property. We're going to solve these not by factoring, but by taking square roots. So we're going to go ahead, and anytime you have something squared, you're always going to get that term by itself. So I'm going to get x squared by itself. A negative divided by a negative makes it a positive, which is good news because once the square is by itself, you're going to square root both sides. When you square root both sides, you have to have positive and negative for your solutions. And simplifying here, we have the square root of 12 over the square root of 5. We're going to use our rationalizing the denominator to get plus or minus the square root of 60 over 5. But 60 breaks down, and so we should end up with positive and negative 2 root 15 over 5 as our final answer. For number 2, we're once again going to get the squared part by itself. So I'm going to move the 2 over, and I'm going to multiply by 5. Once the squared part is by itself, then we can go ahead and square root both sides. On the left-hand side, the square root and the square undo each other, so it's just x minus 4. On the right-hand side, we're going to leave it as the square root of 30 because 30 doesn't break down anymore. Then we're going to move the 4 to the other side, and we cannot combine it because it is not like terms with that 30. So it would be 4 plus or minus the square root of 30. So let's try a couple more. We're going to once again get the squared term alone. Then we're going to go ahead and square root both sides to get 3c minus 1 equals plus or minus root 3. We're going to add 1 over and then divide by 3 to get c equals 1/3 plus or minus root 3 over 3. So I'm going to ask you to try number 4 and then check your answer. As a helpful hint, I'm going to multiply mine all by 8 to get rid of my fraction. So try number 4 real quick. So when we solve that one, we get -3 plus or minus root 26. Thank you very much for listening.